Hey guys, so John here. So I'm going to go ahead and give a tutorial for the new 2-wide uh, hopper speed item categorizer. And this is a world I'm going to be offering for download. So what we have here, so first of all for the video I'm going to go through with a tutorial, then we can give a description of how the machine works, and we can get into some of the mechanics of why this works. But first of all, we're going to say that this is the previous version. This was the newer version, and then we have two variations of the newer version. So first of all, the one that I'm going to give a tutorial on is going to be the green one here, and this is the same one that's set up down there. And the only benefit to this one is that on both of these I was able to kind of lower the height just by reconfiguring the torches here. But with this one is also one block shorter in the depth because I was able to just move the droppers closer to the filter line. So anyway, we'll go ahead and start with a tutorial. So we have two parts. Ugh. We have two parts to the filter here. So we have the actual filter module, and this is what you're going to be repeating to have different outputs. And then we have the input circuit here, which you only need the one input circuit if you're going to be, making multiple slices of the sorter. So let's go ahead and get into the tutorial, and we can just go ahead and make that green. And let's see. So first of all, for the filter, we're just going to be building up here to make it easier to see everything. So a standard filter, you're going to need a filter hopper and then a pull down hopper. The third hopper is going to be our output. So any item that we put in that we want to be sorted into this output, this is where it's going to go. So that's going to be our output there. And then we're going to need a fourth hopper at the bottom, and this is what goes back up into the dropper elevator. So put a fourth hopper there with a chest pointing out. Alright, so we're also going to need an input hopper per slice. So these are 2-wide slices that use 2 hoppers, one for the input and one for the filter. Alright, so to make the filter here, so we're going to come off with glass, put glass there. And glass here and glass there. Okay, so we can take out all of these blocks. So the setup here is going to be a comparator. That's going to come out to dust on the glass, dust on the block, torch below the glass, and then dust moving up onto the glass. And we can get rid of that. And then finally we need a torch at the bottom. So for the input hopper, you're just going to want a couple blocks here. We're going to need a comparator, a repeater at 2 ticks, dust on that block above the repeater with a torch, and then block above that torch with another torch. So finally, to finish the filter, just need some dust there. Alright, so that is the filter section. Next, all we need to do is put in the dropper elevator, and that is going to be down here is where we're going to start. So coming out below the chest there, we can put in a hopper here, and we're going to need our droppers. Alright, so we're going to need 6 droppers, the top dropper, we want pointing back towards the filter. And then the last dropper, we're going to need to point back in this direction, going into a chest. Right? So finally, to complete the item elevator here, we're going to need our observers. So of course we need blocks, we need observers facing forward. Okay, and one extra on the top. And then likewise, we need one extra on the top there. So dust here, repeater, and dust. And then to finish the dropper elevator, just put 3 blocks down here. So we need a comparator, a block, dust, and then a torch coming off of that block. Right? Okay, so the filter section is mostly complete, so we need to just go ahead and use some items for the actual filter. So of course you're going to want an item that's going to be renamed so that you don't end up accidentally putting some type of item in here and then putting another item through the sorter. And likewise, this is going to be our index chest. And so we're going to have to fill the index chest up with items. So you can make that a double chest. Now these are going to be blocker items, and the purpose of the items here is to prevent any unwanted item from coming into this chest. So these are also going to have to be something that you should rename, but you're going to want to make sure that these are not the same as your filter items. Because if these are the same as the filter items, then the filter will of course pull them down and that would break it. But we can get into the setup of that in a second. So for the input, we need an extra 2 hoppers coming off of your first slice here. And for these, we're just going to lay out some blocks. Okay, so coming directly behind this hopper with the comparator, put down a dust. We want a comparator there. Next, you just need a container with an individual item. You can use a furnace here with a stick in it, anything like that. And then we need a comparator coming off of that hopper that is in subtract mode. So block, torch, above this block, put down a comparator. And then we're going to be putting blocks down on the second hopper, on top of that comparator, on top of this comparator, and then on top of the torch. Right? So on all these blocks, put down some dust. Okay. Next, coming down below the nose of the comparator, we're going to need to put down a block with dust. So that way when the comparator detects an item, this is going to get powered. And then coming off of this block, you can put a torch. We don't need those. So above that torch, put in another block with a torch on the face. And this is going to be powering a repeater at 2 ticks. And next above that, put another block, a repeater at 1 tick, another block in front of the repeater, and then we're going to go down with another block with dust there. Right? So this is going to be your input. You can either manually put items in here. If you want to, like I'll show you over there, if you want to use a dropper elevator to put items in, then make sure you have a chest here and that the dropper elevator is going into the chest. Because items are going to start to back up here. So if you want to put in a dropper elevator, make sure it's pointing into the chest here. Likewise, if you're going to be feeding any items in with hoppers, make sure that the hoppers are going into the chest. So this chest is going to act like an immediate storage to catch all the items. You don't want anything to be pushed directly into this hopper. Right? Oh, should not have broken that. But anyway, to finish this, we need to go ahead and set up this because this is actually a filter here. So again, we need 19111, and you can use the same filter items that you use for your hoppers. Okay, and this is almost complete. Now, whenever you're going to connect multiple slices together, the way that this works, this is going to be, okay, so you need to come underneath the dropper with a hopper pointing in that direction, and then we're going to set this up as being the next part of the filter, or the next filter, right? So here, not there, but here we would be putting it in our comparator, repeater, and dust, and likewise this would be where we put in our blocks with our filter hoppers. So it would be like that. Again, the output would come out in this direction and go to the chest there. Yeah. So that would be the general setup. So they're too wide. You can see how they tie together closely. This would be where your next double chest goes, right? Okay. But for the time being, I'm just going to get rid of all this so we can just show you how it operates. So whatever items you want to come into this output, we're going to put in here. So we can just get some items in general. Oops. So remove a couple of your blockers. When you go to set this up, you want to have 2 items of each type of item, right? So now any cobblestone or mossy cobble that runs through the sorter is going to come into the output for this slice. And we can get rid of that. That was for the next filter. Okay, so this would be our output chest here. So we can just put a chest down here. And any item that does not match, so basically anything that's not cobble or mossy cobble is going to pass through, and that would come here, which would go into the next sorter, or this can just be your item output, So if we put anything that is a non-stackable item, let's go ahead and grab something. So of course non-stackable items will just make their way through. And you're going to find those here. And likewise, any item that we put through, so we can just put some cobble, put a couple redstone, and whatever. So any item that is not cobble or mossy cobble will just make it into this output here. Okay. And anything that is cobble or mossy cobble will come out down here. Okay. Alright, so that is the tutorial. And of course with the world download. Now these are kind of big, so I guess this would be one way of making a setup. If you wanted to make them come around a corner, keep in mind that you're going to have to do something wacky like this with the hoppers, because these blocks are going to be powered, and if you tried to feed items through, that would just lock up the items. So you had to make way for the hoppers to come around, but because they're so long, And I can't really find a better way to compact this, but because they're so long, you have to leave a good bit of space between them. But anyway, this would be one way of setting it up. Now I just did this just like a demo, but if you wanted to, you could hang a torch off there to power like a redstone lamp here. And then whenever you go to put items through, then these lights are going to turn on. But in a general setup like this, we have an item elevator, and that is just coming up to feed items directly into the input chest. So we have the input, we have two sorters here, and it goes around to two others here. And in this scenario, you can actually, because we're using this type of item elevator, we're feeding it with a hopper here. So if you wanted to leave the game before the sorter actually finished, so you could just leave a lever here, and whatever items would stop, and then as soon as it finished, sorting out those items, then all the lights would turn off. But right now we just have items making their way around. But you can see we have some junk here already that we're playing with. Yeah, and if I didn't mention it before, they do sort items that stack to 16. So every item will pass through here, nothing will break it. But you can see we have no lights on, so if we wanted to leave the game, we could safely leave the game now without breaking it. The problem is like everything with an item elevator, if you leave the game or unload the area while it's working, then you can end up with an item stuck in one of the droppers, and that would be bad, because that item is either supposed to pass down to the next sorter, or when the machine is in operation, it's going to pull out one of these items, one of your filter items. So if I run a grass block through, it's going to pull one of these out. So if it's in the middle of sorting, and then I decide to leave the area, we could have a grass block stuck in the dropper here, and then that would leave a chance for this to completely pull the items out. Then other random items will start coming up in here. So it's best not to leave the area while it's working. So if you have a lot of items that you want to sort, then just make an on and off switch. That way, if you decide to leave, you can turn it off, let it finish what it's doing, and then you can start again later. But anyway, this is one way of building it, because you can put blocks down here through all of this. You could actually use that as the ceiling. However you want to make it, it's up to you. But we'll go ahead and get into some of the mechanics of how this works. So the way that the input circuit first of all works, so the filter must have a break between item types, okay? And that is what the input circuit accomplishes. So whenever I put any item in, which I've already had a lot of junk in here that I was testing before, but whenever you put in any different item types, so in this case, let's just put in 4 cobble and 1 non-stackable item. So you can watch how the items will pass through. So we're going to have our 4 cobble, we're going to have a 2 hopper gap, and then we're going to have the non-stackable item. So what this does is, no matter what the item types are, whether they stack or don't stack, this will provide you with a space of 2 hoppers between every item type. So if I put in a stack of items, an entire stack, then it will pass through that entire stack of items at full hopper speed. Then it will produce a 2 hopper gap, and then it will start with the next item that's in the chest. Okay, and the reason why we have to do that is because the hopper that we have here, or the comparator that we have reading the input hopper, this has to be able to turn off. So you're going to need at least 2 or 3 ticks for this circuit to turn off before the next item goes into the hopper. So it's very important that you use one of these. Aside from that, the way the filters work, so I mentioned it before, but thanks to Awkward Carrot for designing the elevators, that actually makes this possible. But aside from that, he actually came up with the lower circuit here that will let us have an output, and then using this torch, we can lock and unlock the input for the item elevator. So this is what makes this machine work. So aside from that, we can actually get into some of the mechanics of how this works. And if you've seen Rapscallion's video, why this differs from Rapscallion's video and why we cannot do what he did in Bedrock and have a hopper speed item sorter. So the way that these things work, we can just go ahead and make a little filter here as a demo. So we're going to have our filter hopper, pull down hopper. We're going to have an output for the wanted items, so the items that we want to come out in this filter. And then below that, so just like the larger filters in the back, we can have an output that goes to the item elevator. But in this case, I think I'll just run some hoppers out here so you can see what this is actually doing. So just put in some, since I changed the hopper hitbox, it's a little bit more difficult to actually place the hopper, or to place blocks in front and behind the hoppers. So I'm going to put some blocks down here, and we can just use comparators to detect the output. Alright, we need some glass here. Okay, so glass there, glass here. Remove that block. Need some blocks here. So the filter design that I'm using, why it's different from Awkward Carrot's filter design, this I designed nearly a year ago for my 3-wide half hopper speed item categorizers. So I figured out the mechanics of it back then, but I didn't realize that we could actually use it slightly differently to have a full hopper speed throughput. So back then I just used it for half, but now we can use it for full hopper speed. So anyway, standard filter here, and this is a fast filter. So when the comparator detects an item, it's going to turn off the torch. We have no delay after the torch, so the pull down hopper can pull an item down. This is as fast as it can get, because you have to detect the item, you have to turn off the torch. So this is literally, the fastest type of filter that you can get. So how do we make a categorizer? So first of all, we're going to need some type of an index of items here, right? So we can say that if I want to put in redstone to come into this output, then I need to have some type of index here to say that, to recognize that I put in redstone, so that it can go to the output. But the problem is that because the filter hopper is unlocked, it's just going to pull down any index item that I put in here. Okay. So the first thing we need to do is figure out how to lock the filter hopper. So there are a couple different ways to do that, but we can just say that we are going to take power off of our comparator here, and we're going to use that to turn off a torch, and we can have the torch power up here to lock our input. And I need to go ahead and put some filter items in here. So we'll do our 111 and 19. Oops, that didn't work. Alright, so we got some there, got one there. Okay, so now the filter hopper is locked, so I can go ahead and put some items in here. But we're going to be left with another problem. So if I were to input a redstone in here, then that's just going to turn off, and it's going to pull down everything out of the chest. So I need to limit how much that can actually unlock. So we're just going to use a second torch here. So when this torch turns off, it's going to allow us to pull one item down out of the index, and then this torch will immediately turn on and prevent it from pulling down any more. Okay, so if we go ahead and put our two items back in, then we can go ahead and try the redstone. We can see that this unlocked and only pulled down one redstone, and then we should have one here and one here. Alright, but now we have another issue. So if I want to put in an item that does not match, so you can see the only thing we have here are two redstone. So if I want to throw in, just say, a comparator or a torch, I don't want it to go into this output, I want it to go to the next filter. But what's going to happen is it's actually going to pull down the torch that I threw in, and it's going to send that to the output. And then if we look, this is supposed to go back to our item elevator. So this would come back up and it would push the redstone back in, which would be fine. But it sent a torch to our item output. So why did it do that? Well, the problem that we have now is that because we have the comparator turning off a torch to unlock the filter, this adds a 1-tick delay, right? But you can see down here, the comparator is also turning off this torch, which is going to unlock the pull-down hopper at the same time. So because the pull-down hopper is pulling down an item the same time that the filter hopper is unlocking, then that's causing it to break. So we need to add more delay down here. All right? So we add a repeater there. So a sequence of events are when we put an item in, comparator detects it, that's going to output a signal here, turn the torch off, which is going to unlock the filter to try to pull down a matching item. The next 1 tick later, the pull down hopper is going to unlock, and that's going to pull down our items. So whether it matches or whether it doesn't match, it should work fine, right? So if we put a redstone, so you can see we have one redstone on our output and one redstone going to the item elevator to go back up into the chest. And then if we put in a comparator, okay, so nothing in our output because it did not match, it did not pull down a redstone, and it just sent the comparator to go to the item elevator, which will go to the next filter. Alright, so it looks like it works, but what about if we try to feed this items at hopper speed? Right, so let's go ahead and try to put some items in here. So we'll just give it 6 items there, and let's see what happens. Alright, so they did not match, so it did not pull down a redstone, but what did happen? Okay, so now we have non-matching items moving into the output, and of course one went to the comparator. So it did not work. So why does it not work? Well, the reason why it did not work is because in actuality this setup is just too slow. So to try to make this work, we can actually see what Awkward Carrot did, which he put a torch here. And what the torch allows it to do is feed the items at the correct time to allow them to pass by the filter, right? So with that setup, just by putting a torch here, that will actually allow all of our comparators to go into the next filter. But this also introduces another problem, which we can see if we just go ahead and put down a lot of items, is that our output is no longer hopper speed. And in fact, this is that is operating at a 5-tick clock. So it's like, like 7/8 hopper speed, something like that, which is, still better than anything we had prior to this. But some of the issues that he had with his sorter, because I was talking to him, we were going over it. So it's very hard to control because of this irregular beat. So hoppers have a 4-tick delay between moving items. So 4 ticks with the 5-tick clock, it's just hard to, it's hard to design around, because it just doesn't naturally mesh with each other. But anyway, so what else can we do to actually get this faster? Well, that brings in the sorter that I previously had designed, which uses the input hopper to detect whenever we have an item. And what this does is we actually use the input hopper to lock and unlock the filter, right? So now we can get rid of all this mess. Okay, and of course we need 2 torches here to be able to relock the filter hopper after we unlock it. So using the input hopper here, we can actually unlock the filter hopper before this comparator turns on. So whenever a hopper or any other container receives an item, it's going to be in there for at least 1 tick before the comparator detects it. Okay, so using this method, we can say that when the item is in this hopper, we can give it a 4-tick delay, and that will allow us to unlock the filter hopper 1 tick after the item has entered the chest. So if we just use a normal filter with this hopper detecting with this comparator detecting the hopper, so the item is in the hopper already for 1 tick, then the comparator actually has a 1-tick delay before it outputs the signal. Okay, so I know it's confusing, but my point is that it just takes way too long to try to use this, and that's why you actually have to slow the input rate down to less than hopper speed to be able to accomplish that. So we're going to use the input hopper. We're going to read that with a comparator because that removes a tick here, and we can actually increase the speed down here by removing that repeater and bringing that back up, or bringing the speed back up. Okay. So now if I go ahead and put some items in, so just say that I put in, if I put in a few cobblestone, so now you can see that it's going to send all the cobblestone down to the item elevator. Nothing is going to go into the output unless it's a match, which we can show here. So we put in some redstone, and now all the redstone is going to come out here, and we're going to be left with 1 redstone to go back up to the item elevator. All right, so I made mention of Rapscallion's video. So if you look at Rapscallion's setup, what he's using is he has the first hopper the filter hopper, he has a pull down hopper and he has a third hopper. So the pull down hopper is pointing down into the third hopper, right? And if you look at the way that he arranges his sorter, so he's got a comparator here, and that goes off to turn off another comparator, right? And this is not going to be a working model. This is just going to be a little, little idea of how it's made. But anyway, let's bring that out one more. All right, so he has the input being detected by, or the filter hopper being detected by a comparator. That is going to turn off another comparator here. And then he uses the signal from this hopper to come down, or from this comparator to come down and power another comparator that is going to lock and unlock the pull down hopper. Okay, so I know this is kind of chunky, but whatever. It's just to show the timings that he uses. Okay, so in our first little demo there, so we had a comparator that was turning off a torch, right? And then the comparator turned off the torch at the bottom, which we had to go through a repeater. So the first model that we tried that did not work, that broke, is essentially the same timing as Rapscallion's. Okay, so he used a comparator to turn off a comparator. So that's the same thing as saying that we are using the comparator to turn off a torch. You know, so in Minecraft Bedrock, Rapscallion's sorter would never work. It's just way too slow. So just speculating, there are two ways that he's able to accomplish this. So first is either that Java, the comparators either detect when items are in the hopper faster than in Bedrock, which may be the case. But secondly, he also, if you look at his pull-down hopper, that's pointing down. So in Java, when you have a hopper pointing down into another hopper, then that will give you double hopper speed. So I'm thinking he makes use of the double hopper speed pull down here to avoid the cooldown of the hopper. So what that means is that when this hopper pulls down an item, that it doesn't have to wait for redstone ticks to pull down a second item. So we can't do that in Bedrock. No matter which way you point a hopper, whether you point it down, no matter what, it's going to have a four redstone tick cooldown. There's no way to avoid it. In Java, they can avoid it. So for reference, you can look at Ilmango's. I think he's got a double hopper speed item filter that uses this idea of double hopper speed just from pointing one into the other. But yeah, for us, that does not work. So I think that may be how he is accomplishing a faster action with having a slower filter. But for us to be able to do that, it just would not be able to keep up with hopper speed. We'd just be dumping items in and it would just break. So that's why I came up with the method that I have here to use two hoppers. So we use two hoppers, we use two comparators, and you can see that we can have a full hopper speed input as long as you allow a separation between item types so that this comparator can turn off and then turn back on whenever it detects a new item type. So anyway, so just to say, the concept behind this is that when we send in an item that matches, so if I go to throw redstone in, whether I throw in one stack, just one individual redstone, two stacks, whatever, it doesn't matter. This comparator is only going to turn on and then stay on, and we're only going to compare with one redstone. So all the rest of the redstone are going to assume that the filter is going to assume that they are all redstone, right? So if I did not have that 2-hopper gap, then I could throw in redstone and then throw in cobblestone, and it will still think that the cobblestone is a piece of redstone, and it will pull that down into the output. Yeah, so that's why we use the input circuit, is to avoid that scenario. So anyway, that's it for the tutorial and for the little world demo. So if you're interested, you can download this and play around with it. You can see how these are made. And of course, for the little demo here, I only used a single wide chest for the index. You can of course make that a double chest and fill it up with whatever items, and you can test this out and see if you want to use it or not. But anyway, so that's it for the video. Thank you for watching, and I will see y'all later.